I have a fun presentation and story to share with you. It is really interesting to me. The ideas that we're going to talk about are really interesting to me, and I want to share some of the things with you. So when we've done other talking about the sun and the earth and the relationship between them, we've talked about how sometimes when we're sitting outside, we can feel the heat of the sun. So like at lunchtime, if you're sitting outside and you can feel the sun's rays shining on your heads and it feels really hot. Well, when those sun's rays are shining down straight on us, we call those rays perpendicular rays. So part of the day here in Spokane, the sun's rays fall perpendicularly. However, there's some places on Earth where the sun's rays never fall perpendicularly. And so it's really kind of cool to think about that rays are striking straight on, and some places they're not. And maybe you're wondering how that can be. How can the sun's rays be striking the Earth differently? Well, it's because the Earth isn't flat. Now let's come into this mode, and I have a couple things to share with you. I have this piece of clay, and if the sun's rays were shining directly on this, I have a light here. Whoa, that's pretty bright. If the sun's rays are shining directly straight down onto this piece of clay, the rays are coming from the lamp and they're going straight into the clay. Now, the rays are striking into a straight line like that. The rays are coming in perpendicular. It's hard to show you on both screens. There we go. The rays are striking this clay in perpendicular lines. But we know that the Earth isn't flat. Here we have a sphere that I made out of another kind of clay, or another color of clay. And think about the sun's rays striking this. When they strike straight in, that ray is perpendicular. But watch this. When this ray is striking the Earth, it's not going straight into the sphere. And how about this one here? Those rays are all coming into the sphere, but you can see we can see they're all lined up looking down this way. But when we look at it this way, we can see that although this one is striking the Earth straight on, these ones, it's striking at an angle. It's not striking straight. If you were standing right here, the rays would be coming in right on top of you. But if you're here, they'd be coming along the side of you. There is a name for these rays. I'm going to shut that light off. It's super bright. There is a name for these rays that aren't striking perpendicular. These are called oblique. Oblique rays never make perpendicular angles to the Earth. And so I have a chart I would like to share with you when we look at this. Here I have a picture of the Earth. In this first one over here, you can see that the sun's rays are striking perpendicular to the Earth. And so they're this deep, intense, dark red. And these rays are hottest where they're striking perpendicular to the Earth. Here you can see the rays are striking up here on the northern, well, I assume it's the top pole, the northern pole, and they're not perpendicular, they're oblique. And these rays are making this red color. It's not as intense, it's not as dark and bold as these perpendicular rays are, but it's lighting a bigger space, but the rays are not as intense. So I want to show you how you can see this in another way. I have this piece of black paper here, and I have a white colored pencil, and I couldn't find a flashlight, but I have one of these reading lights, and so we're going to use this as our flashlight. Okay, so we can see that it's light. When I'm holding this light pretty close, like straight on, so it's shining straight perpendicular to the paper, you can see that it makes a circle about like this of really intense light. Oh, you can't see the line. There you go. It's showing that intense circle of white light. But if we just do this, if we leave the same intensity, we use the same light bulb, but all I do is rotate it, you can see that when the angle is not pointed straight down, you can see this whole area that's lit up. Sorry, I'm going to hold it so that I can draw with my other hand. You can see that when it's not straight on, it creates this bigger space. That area is all being lit up because it's off to the side, as opposed to when we're holding it and the rays are straight down perpendicular. So when the rays are striking the earth perpendicular, we got much more intense bright light in this smaller concentrated area. And when the rays were oblique, striking the paper obliquely, it was brighter here, but all of this area, all of it got lit up, but it was much less intense. And we saw the same thing when we looked at this picture. When the rays were striking perpendicularly, they're hot in one concentrated place, but when they strike obliquely, a lot of space lights up, but not as intensely. I have another picture to share with you that shows this idea. Here I have a chart. Move these guys out of our way. Here I have a chart that's showing these perpendicular rays. These sun rays are coming down and striking the Earth's surface, and they're coming down striking perpendicular to the Earth's surface. We can see all of these rays. Here at the bottom, see if I can get that in there. I'm gonna have to hold it just like that. Here at the bottom, you can see that the rays are striking at an oblique angle. And even though they're hitting the same surface, it's hard for you. I don't have enough room. This length right here takes 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 rays are heating that much land. When we look at this other end, we can see that only 1, 2, 3, 4, 5, 6, 7, 8 rays are lighting the same amount. So even though it's the same amount of space as being lit, it's half as much heat, half as much energy with the oblique rays as with the perpendicular rays. Perpendicular rays are more intense and put off more heat and light in this concentrated area, whereas oblique rays light a bigger space but have less intensity and less energy. I have one more chart I want to share with you while we're talking about this idea, because for some of you, all of that was a review, and this might be the new part. If that was new for you, that's great. And then this is also new. This is showing the Earth down here in this brown, earthy dirt color. And then this is a perpendicular ray, and this is an oblique ray. And this dotted space down below here, this is showing the atmosphere. Now, we've talked a lot about the atmosphere when we've talked about the barosphere work, and the atmosphere is the lightest layer of the Earth. It's the gas that floats above the surface. And so when we have a perpendicular ray, the perpendicular ray only has to travel through this much atmosphere. And so it loses very little of its energy as it passes through the atmosphere. You can see this oblique angled ray. This oblique ray is traveling from the atmosphere from here all the way to the surface. So this oblique ray is losing lots of its energy and its potential as it travels through that thick band of the atmosphere. So the perpendicular ray has less distance to travel through the atmosphere, and the oblique ray travels much further through the atmosphere. So as it goes through the atmosphere, it loses a bit of heat. And if it goes through a lot of atmosphere, it loses a bit more, or quite a bit more heat. That's another reason why perpendicular rays are hotter than oblique rays. I have lots of stories to share with you about the sun and the earth and rays and how that affects all of the things on Earth. And I can't wait to share them with you, but those are stories for another day. I hope to see you next time. Bye-bye.